everybody, we're getting ready to do Chapter 9, Review and Summary, Classwork lesson. And for today's lesson, we got Chapter 9 Summary. And we got Part 1 here. And you got 80 points for your classwork sheet, which you should have in front of you now, students. Name, date, period, and if you're onliner or homeschooler, put your due date here. Chapter 9 Summary. Recognize a conic, intersection of a plane, blue of a double-naped cone, write equations of circles, write equations of parabolas, reflective property of parabolas, etc. So today's bell work, teachers and students. An equation and 4 variations are given. So we have this equation here. We got 4 variations down here. In your own words, students, describe how the graph of each of these variations differs from the graph of the original. So this is your original. Tell or write how these are different than from this graph here. Each one of these variations in these boxes here. Give your students about 5-6 minutes, teachers. Pause your video and see. Excuse me. And see you in 5 minutes. Okay, everybody, welcome back for today's solutions for our bell work. So, variations here of y squared equals 8x. How is this different here? It's a vertical translation in this situation here. This will be your vertical translation. And then this one down here would be a horizontal translation. Now we're moving horizontally. And then this one would be a reflection in the y-axis, meaning that you're going to have something go like this versus like that. And then this one down here will be a vertical shrink. So your slope of your parabola will change because of that number there. Moving right along in today's review and summary of Chapter 9, we'll start with 9.1, write equations of circles in standard form. So if you remember, the standard form of the equation of a circle with a center at the origin, with a center at HK. So HK would be your center here. And then the standard form would be x minus quantity x minus h squared plus y quantity y minus k squared equals r squared. So the standard form of the equation of a circle whose center is the origin, hk, equals 0, 0, is x squared plus y squared equals r squared. So if we try one here, write the equation of a circle in standard form. Then identify its center and radius. Students, this is yours down here. I'll do this one in class. So we have 1/2 x squared plus 1/2 y squared equals 18. So we got to get rid of this fraction. We multiply it through by 2. We end up with this, x squared plus y squared equals 36. So our center is now at 0, 0, and we have a radius now of 6 for our circle from this equation here. And then we go into 9.2, write equations of ellipses in standard form. So here is a horizontal major axis would be underneath our a squared. This is our major axis here. This is our minor axis. And then in this situation here, we have a vertical major axis, or a squared will be underneath our y quantity here. So that way you know that it would be a vertical major axis. So let's try one of those. Find the center, vertices, foci, and eccentricity of the ellipse, of this ellipse here. and then sketch its graph. Use a graphing calculator to verify your graph. So we have x squared over 4 plus y squared over 16 equals 1. So in that situation, we have in this situation here a equals 4, b equals 2. This would be our 4, that would be our 2. And then c will be 16 minus 4. Radical of 16 minus 4 would be radical 12, which is 2 times square root of 3. So our center would be at 0, 0. And then our vertices will be 0 plus or minus 4. Our foci, using our known formulas to find that, would be 0, then plus or minus 2 times radical 3. And then our eccentricity, which would be c over a, which we have discovered up here, be 2 times square root of 3 over 4. And that becomes radical 3 over 2. So that would be our eccentricity there. So do the same thing down here, students, for this one. And then, oh yeah, here's your graph here. Major axes here would be underneath your y quantity. So your major axes will be vertical. And this describes this ellipse right there. Okay, moving on to 9.3. Find asymptotes of and graph hyperbolas. Here's a nice hyperbola here. So y equals k plus or minus b over a times quantity x minus h. That would have a horizontal transverse axis. And then this one will have a vertical transverse axis. We switch our fraction out here, and that changes our the way our axis is oriented. Will be a over b is a vertical, and then b over a will be a horizontal transverse axis. There's your difference there, b over a versus a over b. And then in this situation, excuse me, so find the standard form of the equation of the hyperbola. Here's our hyperbola. Put that in standard form. And B, find the center, vertices, foci, and eccentricity of the hyperbola. And then C will be sketch the hyperbola. So for this hyperbola, so what we have here is 5y squared minus 4x squared equals 20. We got to get this to equal to 1. So we divide through by 20. Excuse me. And this is what we end up with here. So that would be your A. That would be your standard form here of a hyperbola. And then B, find the center vertices, foci, and eccentricity of the hyperbola. So A will equal 2, B will equal radical 5. And then C will be radical 4 plus 5 would equal 3. Our center would be at 0, 0. Our vertices would be 0 plus or minus 2. And then our foci would be 0 plus or minus 3. And then our eccentricity would be a c over a, which would be 3 over 2, which is greater than 1, which is a indicator that it is a hyperbola. Going now into 9.4, graph curves that are represented by sets of parametric equations, and rewrite sets of parametric equations as single rectangular equations by eliminating the parameter. Okay. One way to sketch a curve represented by parametric equations is to plot the points in the xy plane. Each set of coordinates xy is determined from a value chosen from the parameter t. To eliminate the parameter in a pair of parametric equations, solve for t in one equation and substitute that value of t into the other equation. The result is the corresponding rectangular equation. So to do that, we have an example here, and we have x equals 2t, y equals 4t. Sketch the curve represented by the parametric equations. Indicate the orientation of the curve. Then eliminate the parameter and write the corresponding rectangular equation whose graph represents the curve. Adjust the domain of the resulting rectangular equation if necessary. Okay, so to do that, we're going to let t equal x over 2 in this situation here. T will equal x over 2, and then we plug that in. Y equals 4 times x over 2, so y equals 2x. So there is our first step in eliminating our parameter. Then once you do that, you can continue on to solve that one. 9.5, convert equations from rectangular to polar form and vice versa. So to convert a rectangular equation to polar form, replace x by r cosine theta and then y by r sine theta. Converting a polar equation to rectangular form is more complex. So convert the rectangular to polar. We're going to go from rectangular here to polar, rectangular here to polar. So to do that, we have to use our r cosine theta and our sine theta in place of our x and y here. And then when we do that, we have to use trigonometric identities to help solve these things. So we have 4r squared cosine squared theta plus r squared times 1 minus cosine squared theta. So we have we can combine now like terms here, and then we end up with r squared multiplied by 3 cosine squared theta plus 1. So this cosine squared here, see 4r squared, that'd be 5r squared. Oh, this 4r squared cosine squared theta plus r squared 1 minus cosine squared theta. So that would give us our 3 cosine squared theta because we're subtracting this from this over here. And then we can factor out an r cubed now. So you have r cubed multiplied by 3 cosine squared theta plus 1 would equal 1. And then we go ahead and then we solve for r squared here. R squared would equal 1 over 3 cosine squared theta plus 1. Excuse me. And then on into 9.6, graph polar equations by point plotting. So, and then use symmetry and zeros as sketching aids. So the graph of a polar equation is symmetric with respect to the following when the given substitution yields an equivalent equation. So for number 1, line theta would equal pi over 2. Replace r theta by r, then pi minus theta, or negative r and negative theta. So that would be one way to substitute. And then a polar axis, you would replace r theta by r and then negative theta, or negative r, then pi minus theta. So for polar, you'd have a different method here than you would where your line theta is pi over 2. And then a pole, you would replace r and theta by r and then pi plus theta, or negative r and theta. So an example of that, identify then sketch the graph of the polar equation here. R equals 2 minus 6 cosine theta. And then this one down here, r equals 3 minus sine theta. So identify and then sketch the graph of the polar equation. Identify any symmetry and zeros of r. Use a graphing calculator to verify your graph. So for this one up here, we have r equals 2 minus 6 cosine theta. It is a limicon because we know the forms of what limicons are, and this is a classic limicon formulation here with an inner loop. Symmetry will be the polar axes, and then the maximum of value for absolute value of r would equal 8 in this situation when theta equals pi. When theta equals pi, it would be 8. And then our zeros would be r equals 0 when cosine theta equals 4, and then which becomes theta is 1.231, and then our other coordinate would be 5.052, would be another 0 for this function here. And then this will be your graph here. Here's a graph of this r equals 2 minus 6 cosine theta. It would look like that. And then moving right along here, we have 9.7. Define conics in terms of eccentricities and write and graph equations of conics in polar form. So the eccentricity of a conic is denoted by E. The conic is an ellipse when 0 is less than E is less than 1, a parabola when E equals 1, and a hyperbola when E is greater than 1. The graph of a polar equation of the form like this, r equals EP over 1 plus or minus E cosine theta, or r equals EP over 1 plus or minus E sine theta. So these are the forms here of a polar form of a conic, where E is greater than 0 is the eccentricity, and the absolute value of P is the distance between the focus, otherwise known as the pole, and the directrix. So your P distance here would be designated by that, between your focus and the directrix. So identify a type of conic represented by the equation. So here's our equation. Then use a graphing calculator to graph the polar equation. So for r equals 5 over 6 plus 2 sine theta, we can tell just by looking at it, when we stick in our values here and we solve for to get our denominator in standard form, we have to divide through by 6, and we end up with this form here, which E is 1 over 3, so which is less than 1. So we know this is an equation of an ellipse, and this would be the graph, the elliptical graph of this representation here. And that is chapter 9, review and summary. Here's my email, animatedpowerpointmathvideo@aol.com, for resources, and for questions, email me there. Thank you very much.